Hey guys, so we are starting our new unit today. Sorry I'm not here, but it is going to be all about factoring polynomials, okay? So we are going all the way back to polynomials, and we are going to do this thing called factoring them. Just to remind you about polynomials are when you have many terms. So all of these are polynomials. They have a bunch of different terms. Terms are, have the plus or minus in between them, and then they have variables as well. So the first thing that we are going to do is we are going to show or remind ourselves how we simplify polynomials. So if you remember, you just distribute. 3a times 3a is going to be 3a squared, and a times 7 is going to be a positive 7a. And then negative 2m times m squared is going to be negative 2m to the third power. And then negative 2m to positive 6m is going to be a negative 12m squared. And then a negative 2m to a negative 1 is going to be a positive 2m. So remember, when you are multiplying with exponents, you keep the base and you are adding the exponents. So like here, this third one, we're doing 4x to the third y times x squared. So your 4 will stay the same because there's nothing to multiply by. Your x will become x to the fifth, and your y will stay the same because there's nothing to multiply by. Then when you do it to the negative 2y, you have a negative 8. Your x will stay the same because there's nothing to multiply by. Your y will become y squared. Okay, so we just simplified all of these different polynomials by applying exponent rules and multiplying coefficients. So what we are going to do when we're factoring is we are going to go backwards. Okay, so factoring is separating a polynomial back into a product. Remember, product is multiplication. So this is a product, this is a product, this is a product. Okay, so we're going to go backwards. We're going to start out with this something like 3a squared plus 7a, and we're going to work it backwards to this product. That is what factoring is. And so again, simplest form, an example of that, you guys can write that 4a squared plus 8a would be its simplest form. But when you work it back into a product, you are working it back to 4a parentheses a plus 2. I'm sure some of you can tell that all that we did was we took out a greatest common factor, and that's how we're going to factor today. Polynomials that cannot be factored are called prime. Okay, so here's how you do it. So there are several factors when there are several methods. We're going to learn basically one each day. The approach depends on the polynomial, but we will always start, always, by factoring out the greatest common factor of the polynomial. So here's how we're going to do that. Step number 1 is identify the GCF. Check the coefficients for GCF. You always want to check the numbers first and see if you can find a GCF. Then look at the variables. A variable can be a part of your GCF only if the variable is present in every single term. For example, there is no x here in the 12. Therefore, the variable x cannot be a part of this polynomial's GCF. Not possible, okay? Once we identify what our GCF is, we're going to divide each term by that GCF, and we're going to take it out of the parentheses to the front. Whatever is left will go in the parentheses, and we can always check our work by distributing. Okay, so let's look at this 3x plus 12. Like we said, we just talked about the fact that there is no variable in 12, so x cannot be a part of our GCF. So look at your coefficients of 3 and 12. The greatest common factor between 3 and 12 is a 3. So we're going to pull out a 3. That's going to be outside of the parentheses. What's left inside the parentheses is everything after I divide by the 3. 3x divided by 3 is just x. 12 divided by 3 is a positive 4. So that is the factored version of this polynomial. Okay, let's look at number 3. 8m plus 36n. Unfortunately, the m and the n are different, so that cannot be a part of my GCF. So let's look at just the 8 and the 36. The GCF, or the greatest common factor, for both of these is going to be a 4. So when we take out a 4, that's our GCF. Divide. 8m divided by 4 is 2m. And 36n divided by 4 is a positive 9n. You can always, again, distribute it and make sure that you got it correct. Okay, now let's look at something like number 6. Number 6 has a y in both of the terms, so it can be a part of our GCF. Okay, the other part of our GCF, we look at the coefficients. 4 can go into both of these, so we know that we can have our GCF be a 4 and a y. So I'm going to take out a 4 and a y. The reason why I'm only taking out one y is because that is what is the lowest here. I can't take out a y squared. This one doesn't have a y squared. Okay, so I can just take out, so you're going to take out, when it comes to your variable, you're going to make sure that you take out the lowest exponent of that variable. Okay, so I'll say that again a couple other times, but you're going to make sure when it comes to the variable, you're taking out the lowest exponent of the variable. So now we're going to divide everything by 4y. Well, 4y squared divided by 4y is going to give us just 1y. And negative 24y divided by a 4y is going to give us a negative 6. Again, you can check it by multiplying. 4y times y is 4y squared. 4y minus 6 is a negative 24y. Okay, let's look at something like 10. We've got two variables here. Okay, so we are going to look at, each has a b, so that's good. I can take out a b for my GCF. And then each has a c, but again, I'm looking for the lowest exponent, so I can only take out one c. Out of the 16 and the 24, I can again use my GCF of, let's see, I can use h this time. So I am going to pull out our 8 and our b and our c, that's outside the parentheses because that's our GCF. 16 divided by 8 is 2. B cancels out, C I have 1 left. Plus 24 divided by 8 is 3. B's gone, C's gone. When I divide, again, remember I'm dividing by the 8BC. And that is how I get this factored polynomial. Okay, so y'all are going to go through these problems and you're going to pull out your GCFs for every single one of them. Let's look at some of these bigger ones. Let's look at something like number 20, okay? It's just more to keep up with. You got 3 variables. We want to make sure that we take out the greatest common factor of the variable and of the numbers. So looking at the numbers, we've got 18, negative 24, and 36. Okay, so what you're looking at, what is the greatest common factor there? You know that 6 can go into all of them. So let's see if that's the greatest common factor. Let's use a 6. Each term does not have an x. Because each term does not have an x, it is not a part of my GCF. Each term also does not have a y. Because each term does not have a y, it is not a part of my GCF. Each term does have a z though, so I can divide by a z, and the lowest exponent is this z to the first power technically, so I can just take out a z. Okay, so let's see. 18 divided by 6 is going to be 3. My x stays the same, my y stays the same, my z is gone. Negative 24 divided by 6 is a negative 4. My x is the same, and I'm dividing out one z, so I'm left with one z. 36 divided by 6 is a positive 6. My y is still there, and then I'm dividing out one z, so I'm going to use my exponent skills again of subtracting 3 minus a 1 here to give me z squared, and that should be my factored polynomial. 3 can't change, 4 can't change, positive 6 can't change. Those don't have a GCF, so this is done. Okay, so this is what you guys are working on today. If you finish through 24, again, it's just finding the greatest common factor. If you guys finish, you are going to make sure that you check it on Canvas and then do some Delta Math. Delta Math will also have videos, which are nice. If you guys are not finished, try and finish them over the weekend. Try and get at least a couple of these harder ones. This is going to be your first step in every single thing that you factor, so I want y'all to get really good at it. And yeah, so we will talk more about this on Monday. Look at number 13. Does anything go into it? There's the bell. But 13 would be an example of something that would be prime. So y'all go through this, and then we'll talk about it on Monday. Hope y'all have a great day. Bye.